Now, what is happening? Suddenly, let us assume, suddenly human being discovered that fish is a commercial species, for its taste. Okay. So, obviously, economics will coming, economics will enter into our discussion. So, once again let us assume that y t is rate of extraction or rate of catch of fish, x t indicate stock, then c is again a function of cost of catch and then P t is the price of fish. So, our objective functional is maximize, what we are going to maximize, integration 0 to t again P t into y t, the revenue, P t into y t, okay, minus c of y t into x t, okay, and e to the power minus r t d t. The same objective functional in the non-renewable resource, but the constraint will change. Constraint will change as x dot t, that means rate of change of the stock is equals to g of x t growth minus harvest. Okay. So, earlier it was x dot t minus y t. If you go back and see in the context of non-renewable resource, since non-renewable resource cannot grow within a economically feasible time horizon, we denoted x dot t equals to minus of y t. Here x dot t equals to g of x t minus y t. So, our control variable once again is y t. Okay. So, our control variable is y t here. Rate of catch, or you can say that rate of harvest. that is it. Okay. Rate of harvest. Now, the optimization requires, once again the first step is what? Do you remember? The first step is the formulating the current value Hamiltonian. So, I will take it in the next page, or let us say that the current value Hamiltonian denoted by H bar. Okay. H bar equals to what I will write, simply P t into y t minus C function, okay, C function y t into x t minus rho t into this g of x t g function minus y t. Okay. This is the current value Hamiltonian, and maximization or optimization require differentiating this function with respect to y t. Okay. Differentiating this function with respect to y t and set it equals to 0, that is coming from the first order condition, sorry. And this implies, if I differentiate the current value Hamiltonian with respect to rate of extraction, what I will get P t equals to C prime plus rho t. Okay. So, that means price should be equals to cost of extraction plus the shadow price, which is similar to our case, previous case. So, price should be equals to marginal cost of extraction plus shadow price, which is rho t. Okay. So, this condition is similar to our non-renewable resource also. Now, from the second step, what we need to do is basically differentiating the Hamiltonian with respect to x t and set it equals to 0. Okay. Sorry, this is the second order condition is coming from this actually, that second order condition, from second order condition we need to differentiate this function with respect to delta x t. So, this is basically how I am deriving the second order necessary condition, and this is equals to if we differentiate the h function with respect to x t, then what I will get, x is here on the cost function. So, I will get delta c delta x t, okay, and I have x in the growth function also, minus rho t into delta g delta x t. Okay. So, from here what I can say that minus of this equals to delta x t equals to minus of delta c delta x t minus, or sorry, plus of rho t into del g del x t, okay, del x t. Okay. Now, what we will do, this minus del h bar del x t, that is basically equals to, we will put the value of this from our earlier condition. Okay. What is the condition we derived? If you recall from earlier condition, what we get, that rho t, this is let us say equation 1, this is let us say equation 1 what we have derived so far, and then what we will do, previously we got one condition, rho dot t, if you recall, rho dot t equals to r into rho t minus del h bar del x t. This is one condition which we derived earlier, this condition. So, that means I can write del h bar del x t equals to rho t minus of this. So, from here what I can write, that minus del h bar del x t equals to, I can say, rho t minus r into rho t. So, what I will do, I will put this value here. Let us say this is equation 2. Okay, this is equation 2. So, from equation 2, 1 and 2, what I can write, that rho dot t minus r into rho t equals to minus del c del x t plus rho t into del g del x t. Okay. Or what we can write, that is that this r into rho t will take other side, and then we will say that rho dot t plus del c dot del x t minus so what we will get, minus rho t into del g into del x t. So, this is let us say we are calling equation 3, sorry, this then would become equals to r into rho t. This is let us say equation 3. Now, we need to interpret this equation 3. Okay, interpret this equation 3. So, let me check whether we did the everything correctly. This is this. So, this should be equals to minus of this. So, rho dot t minus rho dot t equals to r into rho t minus del h is equals to this. So, sorry, this is plus actually, this is plus. So, this would become minus, this has become minus, and then if this is minus, then rho dot t equals to this. So, ultimately this would become this. So, ultimately this would become plus. Okay. Now, in this equation 3, basically again like the non-renewable resource case, in this case equation 3 indicates total benefit of preserving the renewable resource. So, equation 3 indicates equation 3 indicates total benefit of preserving the resource, renewable resource, for tomorrow. Okay, that is what. All right, this is what we say. So, here this should be plus, okay, this should be plus. So, unlike the non-renewable resource, when we talk about renewable resource, the current value Hamiltonian is this plus lambda t into this, because if you put it plus here, that means you are deducting the extraction plus adding the growth. So, this should be plus, and as a result of which when you differentiate this should be also plus. So, there are 3 components in equation 3. Let us say this is the first component, then this is the second component, and this is the third component. So, first component indicate capital gain like the non-renewable resource, capital gain. Second component indicates what? Similar to the non-renewable resource, stock effect on cost of extraction, on marginal cost of extraction, or let us say on cost of extraction. Now, the third component of the total benefit is actually missing. in non-renewable resource. This additional term, what is this indicating? Look at this. This is basically benefit for biological growth. Biological growth was not there in the context of non-renewable resource. If I preserve the resource for tomorrow, my fishes will grow, and if I want to convert that growth into benefit, obviously I have to multiply that with rho t, because that is the shadow price. That is why third component basically indicate benefit due to biological growth, which was absent earlier in the context of non-renewable resource. So, these three are the benefit if I preserve the resource for tomorrow, and that should be equals to at least R into rho t. I can always catch the fish, and the revenue part I can keep it in bank. Bank will give interest at the rate of R. So, my total benefit would be R into rho t. Okay. That is what we meant. So, this is the total benefit. So, this is total benefit. Okay. Total benefit from preserving the resource. And R into rho t, that basically indicates total cost of preserving the resource for tomorrow. So, at equilibrium, total benefit should be equals to total cost. That is why this equation says total benefit of preserving 1 unit of renewable resource should be equals to total cost of preserving the resource at equilibrium. So, when these two things are equal, then we say that we are on the optimum path of extraction. Okay, right? Optimum path of extraction. So, at steady state, so if there is no radical change in demand and cost condition, there is no radical change in demand and supply condition, then first order necessary condition FNC and SNC, second order necessary condition, leads to a steady state. Situation where basically x dot t growth of the stock equals to 0. That means g of x t growth is basically equals to the rate of harvest. And when x dot t equals to 0, that implies there is no capital gain also, rho dot t also equals to 0, because this capital gain arises due to change in stock only. If there is no change in stock, then there is no change in price, because we assume there is no radical change in demand and supply condition. So, with this we are closing our discussion today, and we will meet again in our next class to discuss the remaining portion of this resource economics. Thank you.